Jai Hind everyone. Myself Mani Dublish, Assistant Professor in MCA Department in Akgec Engineering College. Today I am going to cover the topic of searching. Uh, what is searching process, and what is the searching algorithm. So, uh, 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 in today's lecture, I am going to cover what are the local search algorithm. So, first one I have covered in this lecture is hill climbing algorithm in artificial intelligence. So basically, hill climbing algorithm is a local search algorithm which continuously move in the direction of increasing elevation value to find the peak of the mountain or best solution to the problem. So basically, it terminates when it reaches a peak value where no neighbor has a higher value. So hill climbing algorithm is a technique which is used for optimizing the mathematical problems. So one of the widely discussed example of hill climbing algorithm is traveling salesman problem, in which we need to minimize the distance traveled by the salesman. Again, it is also called greedy local search, as it only looks to is good immediate neighbors state and not beyond that. So the node of the hill climbing algo has two components, which are state and value. Again, hill climbing is mostly used when a good heuristic is available. In this algorithm, we don't need to maintain and handle the search tree or graph. It is graph, as it is only keeps a single current state. What are the feature of hill climbing algo? So the following are the main feature of hill climbing algo. First one is the generate and test variant, greedy approach, and no backtracking. So hill climbing is a variant of generate and test method. The generate and test method produce feedback which helps to decide which direction to move in the search space. Greedy approach, hill climbing algorithm search move in the direction which optimize the cost. No backtracking means it does not backtrack the search space, as it does not remember the previous state. Now we have three types of hill climbing algorithm. First one is simple hill climbing. Second one is Steepest Ascent hill climbing. Third one is stochastic hill climbing. Now, what is simple hill climbing? So simple hill climbing is the simplest way to implement a hill climbing algorithm. It only evaluates the neighbor node state at a time and select the first one which optimizes the current cost and set it as a current state. It only checks it is one successor state, and if it is find better than the current state, then move also be in the same state. So this algo has following feature. First one is less time consuming, and second one is less optimal solution, and the solution also is not guaranteed. Algorithm for simple hill climbing. First, we evaluate the initial state, loop until a solution found or there is no operator left to apply. Select and apply an operator to the current state. Next, check new state. If it is goal state, then return success and quit. Else, if it is better than the current state, then assign new state as a current state. Else, it's not better than current state, then we can return to the step to finally exist. Now, what are the problem arise in hill climbing algorithm? First one is local maximum. So local maximum is a peak state in the landscape which is better than each of the neighboring state, but there is another state also present which is higher than the local maximum. So the solution of this problem is backtracking. So what is backtracking? Basically, backtracking technique can be a solution of the local maximum in state space landscape. So create a list of promising paths so that the algorithm can backtrack the space and explore other path as well. So this is the solution for local maximum problem. Second one is plateau. Plateau basically is a flat area of the search space in which all the neighbors state of the current state contains the same value because of this algorithm does not find any best direction to move. So a hill climbing search might be lost in the plateau area. The solution of this problem is the solution for the plateau is to take big steps or very little steps while searching. To solve the problem, randomly select a state which is far away from the current state. So it is possible that the algorithm could not find non-plateau region. Next one is ridges. So a ridge is a special form of the local maximum. It has an area which is higher than its surrounding area, but itself has a slope and cannot be reached in a single move. So the solution of this problem is with the use of bidirectional search, or by moving it in different direction, we can improve this problem of ridge. Now we have simulated annealing. So a hill climbing algorithm which never makes a move towards a lower value guaranteed to be incomplete because it can get stuck on a local maximum. And if an algorithm applies on a random walk by moving a successor, then it may complete but not efficient. So simulated annealing is an algorithm which yield both efficiency and completeness. So simulated annealing, in which the algorithm picks a random move instead of picking the best move. If the random move improve the state, then it follows the same path. Otherwise, the algorithm follows the path which has the probability of less than I, or it moves downhill the choose we can another path. Next type is the steepest ascent hill climbing. So steepest ascent algorithm is a variation of simple hill climbing algo. So this algorithm examine all the neighboring nodes of the current state and select one neighbor node which is closest to the goal state. So this algorithm consumes more time as it searches for the multiple neighbors. Uh, Stochastic hill climbing does not examine for all its neighbors before moving. Rather, this search algorithm select one neighbor node at random and decide whether to choose it as a current state or examine its another state. So next part, the example is we have mean and analysis in artificial intelligence. So in this we have studied the strategies which can reason either in forward or backward, but a mixture of the two direction is appropriate for solving a complex and large problem. Such as a mixed strategy make it possible that first to solve the major part of the problem and then go back and solve the small problem arise during combining the big part of the problem. So this kind of techniques generally we known as mean and analysis. So mean and analysis are problem solving techniques which we use in AI for limiting search in AI programs. Also, we can say it is a mixture of backward and forward search technique. The MEA technique was firstly introduced in 1961 by Alan Newell and Hebert. So, a Simon in their problem solving computer program which was named as Journal Problem Solver GPS. So, the MEA analysis centered on the evaluation of the difference between the current state and the goal state. So now the question arises how the mean and analysis works. So the mean and analysis process can be applied recursively for a problem. So we can say it is a strategy to control search in problem solving. Following are the main steps which describe the actual working of MEA technique for solving any problem. First, evaluate the difference between initial state and final state. Secondly, select the various operator which can be applied for each difference and after apply the operator at each difference which reduce the difference between the current state and the goal state. Now, the what is operator subgoaling which we used in MEA process. So in the MEA process, we detect the difference between the current state and the goal state. So once these differences occur, then we can apply an operator to reduce the differences, but sometimes it is possible that an operator cannot be applied to the current state. So we create the subproblem of the current state in which operator can be applied, such type of backward chaining in which operator are selected and then subgoals are set up to establish the precondition of the operator which is called operator subgoaling. Now, algorithm for mean and analysis. So, let me take current state as current and goal state as goal. So, what would be the following step? First, we have to compare current to goal. If there are no difference between both, then return success and exit from the uh, uh, algo. Else, select the most significant difference and reduce it by doing the following step until the success or failures occurs. Select a new operator which is applicable for the current difference, and if there is no such operator, then signal failure. Attempt to apply operator O to current, make a description of two states. First one, O start, a state in which all preconditions are satisfied. O result means the state that would result if operator were applied in start. First one is first part tends to current and start, and second part is last part which tends to the result. These are successful, then signal if these are successful, then signal success and return the combining first part and the last part. So these algorithm more suitable for the simple problem, but not suitable for the tough and complex problem. So let's take an example where we know the initial state and the goal state. In this problem, we need to get the goal state by finding the difference between the initial state and goal state by the applying operator. Here we have this initial state and we have goal state. The solution would be to solve the above problem. First, we will have to find the difference between initial state and the goal state, and for each difference we will generate again a new state and apply the operator. So operator, we have the problem are first one or move, second one delete, and third one is its expand. So first one kya, evaluating the initial state. So in the first initial state, in the first step we will evaluate the initial state and will compare the initial state and goal state to find the difference between both states. So this would be the first step. Second one is applying delete operator. As we can check, the first difference is that in the goal state there is no dot symbol which is present in the initial state. So first we will apply the delete operator to remove this dot. Third one is applying move operator. After applying the delete operator, the new state occurs which will again compare with goal state. So after comparing this state, there is another difference, that is the square, it's outside the circle. So we will apply the move operator. Now applying the expand operator, now state is generated in the third step and we will compare the state with the goal state. After comparing the state, there is still one difference which is the size of the square. So we will apply expand operator and finally will generate the goal state. Now second searching algorithm, this adversarial search. So adversarial search is a search where we examine the problem which arise when we try to plan ahead of the bird and other agents are planning against us. So in previous topic, we have studied the search strategies which are only associated with the single agent that aims to find the solution, which generally often expressed in the form of sequence of actions. But there might be some situation where more than one agent is searching for the solution in the same search space, and the situation usually occur, and generally this situation occurs in game playing. So the environment with more than one agent is termed as multi-agent environment, in which each agent is an opponent of other agent and playing against each other. So each agent needs to consider the action of other agent and effect of that action on their performance. So searches in which two or more players with conflict goals are trying to explore the same search space for the solution are called the adversarial searches, also oftenly generally known as games. So games are models as search is problem and heuristic evaluation function, and these are two main factors which help to model and solve game in AI. So we have to think deterministic, two types of game in AI. First one, deterministic, perfect information. Deterministic means chess, checkers, go. Chance move maybe backgammon and monopoly. And in imperfect information, we have battleships, tic-tac-toe, and chance move maybe bridge, poker, Scrabble, or nuclear war. So the perfect information means a game with the perfect information is that in which agent can look into the complete board and agent have all the information about the game, and they can see each other moves. So basically example are chess, checkers. These are the example of perfect information. And in perfect information, if in a game agent do not have all information about the game and not aware with what's going on, or such type of games are called the imperfect information, such as tic-tac-toe, battleship, blind, bridges. These come under the category of imperfect information. Now the deterministic games mean, so deterministic games means are those games which follow a pattern and set of the rules for the games, and there is no randomness associated with the that. So basic examples are chess, checkers, go, tic-tac-toe, etc. And non-deterministic games mean, non-deterministic are those games which have unpredictable event and has a factor of chance or luck. So these factor of chances or luck is introduced by either dice or card. So these are random and each action response is not fixed. So such games are also called as stochastic games, like backgammon, poker, monopoly, etc. Now we have again an example of zero-sum game. So zero-sum game come under the category of adversarial search which involve pure competition. So in zero-sum game, each agent gain or loss of utility is exactly balanced by the losses of gains or utility of another agent. So one player of the game try to maximize one single value while other players tries to minimize it, and each move by one player in the game is called as play. Chess, tic-tac-toe are the perfect example of zero-sum game. Zero-sum game basically is embedded thinking. The zero-sum game involved embedded thinking in which one agent or player is trying to figure out what to do, how to decide the move, needs to think about the opponent as well, and the opponent also thinks what to do. So each of the players is trying to find out the response of his opponent to their actions. It's require embedded thinking or backward reasoning to solve the game problem. So to formalize of this problem, we have some steps. First one, we have initial state, player, action, result. So initial state means specify how the game is set up at the start, and players mean specifies which player has moved in the state space, and actions returns the set of the legal moves in state space. Result is a transition model which specify the result of move in the state space, and the terminus test means terminus test is true if the game is over, else if it is false at any case. So the state where the game end is called the terminal state. So utility means a utility function gives the final numeric value for a game that ends in the terminal state for player P. Again, it is also called payoff function. For chess, the outcome would be win, loss, or draw, and its payoff value are 0, 1, half. And for tic-tac-toe, utility values would be positive 1, -1, and 0. Uh, Second one is game tree. So a game tree is a tree where nodes of the tree are the game states or and edges of the tree are the moves by the player. So game tree involves initial state, action function, result function like tic-tac-toe game tree. So some key point of the game are there would be two player, max and min. So player have an alternate turn and start with max, and max maximize the result of the game tree, and min minimize the result. So this is the figure of a tree where we have utility, terminal, min, max, and min, max. So in today's lecture, I would cover I would break here by the game tree, and in next lecture I will tell you how this min-max algorithm solve. So that's enough from my today lecture.